Welcome to the video series of my database management system. In this video, we'll talk about the indexing in database management system. The indexing in database management system. Here you will be learning about what is an index or indexing, why we need the index or indexing, why index or indexing is there in database, different types of indexing, and the importance of indexing. So I request you, please stay tuned till the end of this video. Please subscribe to my channel, like and share this video. Thank you. Before starting with indexes in database, first we'll see how the index in books and its working. How the index will work in books. So let's start with our indexing. Why indexing is used in computer system? Why we need the indexing? What is the need of indexing? So before understanding the why we need the indexing, let's see the basic architecture of a computer, how the computer works. So in a computer we will be having these three peripherals. First is central processing unit, next is random access memory RAM, and a hard drive, that is hard disk. So coming to the processor where actual processing will take place of the data, its speed is very high. It can calculate or it can process millions of instructions per second. Coming to the capacity is low. The speed of the CPU is measured in terms of hertz. So every processor will be having a certain capacity. It can handle that much of instructions only. So speed of handling that particular instructions is very high. Speed is very high. Next we have RAM. So RAM is volatile in nature and temporary. Why it is volatile in nature? Because as long as we supply the power, the data remains in the RAM. The moment we are going to stop the power supply, the data will be evaporated or erased from the RAM. So RAM, to have the data in RAM, we should supply the power. We should supply the electricity to the computer system. Then only RAM is going to hold the data. The moment we are going to stop the power supply, the data will be evaporated from the RAM, erased from the RAM. The speed of the RAM will be measured in terms of 1000 instructions per second. 1000 instructions per second. So speed is high. So coming to the capacity is low in terms of GB. So in every computer you can see the RAM might be 16 GB, 8 GB, 4 GB, 1 GB, it will be like that. So the capacity of RAM is low compared to our hard drive. So RAM is a primary memory. So next we have hard drive. Hard drive is a non-volatile in nature and permanent. Non-volatile in nature and permanent means once we are going to put the data into the hard drive, if the power supply is off, even we will be having the data. Whereas in RAM, the moment we stop the power supply, the data will be evaporated or erased. Whereas in hard drive, if you stop the power supply, the data will be remain same. Okay, that's the reason it is a permanent in nature and non-volatile. So speed is slow. It can handle only 30 instructions or 100 instructions per second. Coming to the capacity is very high. For every computing device, the secondary memory, that is hard drive, the capacity is always high. That will be measured in terms of TBs. So in our laptops, in our computer system, even in our smartphones, the capacity of our secondary storage is high. For example, 64 GB or 1 TB. Coming to the RAM, 8 GB, 4 GB in our smartphones. So like this, the secondary storage is always having a high capacity compared to our primary storage. So this is our primary memory, this is our secondary memory. So whenever anything the computer wants to process, whenever any query or something the computer want to process, it is going to have the interaction like this. First the instruction will be going to the processor is going to look that particular thing in RAM. So RAM is going to ask the data from the secondary memory. So this CPU cannot communicate with the hard drive directly. The reason is the speed of CPU is very high. The speed of our secondary memory device is very low. That's the reason these two are not compatible to have the communication. That's the reason we are having the mediator, that is our primary memory. The speed is high compared to our secondary memory. So primary memory will play a vital role for the processing. So how it is going to happen, let's see this example. This is our hard drive. So in a hard drive, I have the blocks. Okay, in every hard drive, the blocks will be there. In every hard drive, the blocks will be there. These blocks are logical blocks. In your computer system also, you will be having C drive, D drive, E drive. So all these drives are logical blocks of your hard drive. So why we need these particular blocks? To segregate the data, to arrange the data. Let's take an example. If you want to construct a house, if you want to construct a house, so you will not be constructing only single room, you will be dividing your entire house into rooms different rooms and specific areas. So same like this, we will be having a hard drive. So this hard drive we are going to divide logically, not physically. We are going to divide this hard drive into logical blocks. So these blocks I am going to name as 0 1 2 3 4 5. So let's consider I have only 5 blocks in my hard drive, right? So these particular blocks will be having a data. So I have the data, I have this specific data. So whenever a query comes to the CPU, or a user wants to send if a user is sending a request or wants to execute a query, I want a student detail. For a star, select star from student table, select star from student table. So processor wants to execute the query. What is a query? Select star from student table. Processor wants to execute, right? Now processor needs the data. Processor needs the data to process the query. Is the data is there in processor? No. Where the data? Data is in secondary memory. Data is in secondary memory. So now the processor will instruct primary memory that I want this particular data. So now what the primary memory will look, primary memory will communicate with the secondary memory, and it will check the first block. It will check the first block, 0 block, into the primary memory. It will map the first block of secondary memory into the primary memory, right? It will check the block, whether this block is a desired, whether this particular block is a correct or not, right? So if the processor is checking this particular block is correct, the processor is going to execute the query. If this particular block is not having the desired content, this particular block again replays to the same original place. Next, another block will be coming to the primary memory from secondary memory. This block again, the processor is going to check whether this particular block is correct for desired content or not. If it is correct, the processor is going to execute the query. If it is not correct, again the processor is going to replace it back. So like this, the processor is going to take the blocks into the primary memory, checking the block whether this particular block is correct or not. So this process of copying the blocks from the secondary memory to the primary memory, copying of blocks from secondary memory to the primary memory is our indexing. Just we are going to map this. We are going to mapping. What we are doing? We are just mapping the block from the secondary memory to primary memory. Is our blocking? Is our indexing? Indexing is just to map the block from secondary memory to primary memory. That's it. Whereas to search inside the block, how, whether this particular block is having a desired content or not, it's a query processing. So query processing is not the part of indexing. Indexing is just going to pick the character block. For example, if you are searching for a specific topic in a book, so what you will be doing, you are going to just go to the index, you are going to search for the topic. Yes, this is my topic on so and so page number, so and so page number. So what is the index will do? Index is going to give you the correct page number. That's it. Here also the indexing is going to give you the correct block for the your desired content. So indexing is going to give you the correct block for your desired content. So what is indexing? Searching for correct block for your desired content. In the same way, we have the books. In the books index, you will be having the index wherein you will be looking for the your particular desired content. Yes, this is I want. So you will be looking for on which page number it is. That's it. So once you reach to the page, the real searching will start. So wherein you are going to select for your desired content, the query processing will take place. So once you reach to the block, from there onwards the query processing is going to start, right? So query processing starts once you get the correct page or correct block. So indexing is going, what is our responsibility of the indexing is to select the correct block. It is to map the correct block into the primary memory, right? Is to map the correct block to the primary memory from secondary memory. So this is, that is why we need the indexing. That is why we need the indexing. So index in books. So here we will be having different topics and a page number. In usually in every book we'll be having the serial number of the topic and its respective page number. So whenever you are going to look for any specific topic, for example, if you are looking for dependencies in database, so what you are going to do is you are going to select the topic 3 here and its respective page number 11. So this is an importance of index, why we need the index. So index will help you to select the desired content, to select the desired content. Okay, how you are going to select the desired content? By reaching to the specific page number, by reaching to the specific page number of the book. So this topic will be our search key and a page number will be our data pointer in our database, in our database. So topic will be the same topic. So topic will be called as search key here in database, whereas page number will be called as data pointers in our database. So let's start with this. Index in database. A database index is a data structure. It is a data structure that improves the speed of data retrieval operation on a database, as I've told you. So when all the data will be stored in secondary storage, from the secondary storage, whenever a query comes to the processor, processor cannot communicate to the secondary storage. Processor will ask the RAM to provide the data. So RAM will go to the secondary storage and take that specific block into the RAM. From the RAM, processor will take. So the time taken, or the time taken to search the respective block from the secondary storage and copying that particular block to primary storage, the indexing will look after. So indexing is all about to just to copy or the map the content or the block from secondary storage to primary storage. That's it. So a database index is a data structure that improve the speed of data retrieval only, data retrieval operation, right, on a database table. It is used to locate and access. It is very clear. So what the index is going to do, it is going to locate and access the data in a database table quickly. This process is called indexing. It is not going to do anything more, just the indexing. What the index of the book will do, what the index will tell you where that particular specific topic is located. That's it. So here also in database, the indexing will help you to locate and access the data in database quickly. If you don't have a index in a book, it will take much time to search the specific or desired content, right? So same way, the index will help you, or the indexing will help you in database. So indexing is used to optimize the performance of database by minimizing the number of disk access required when a query is processed. So as I have told you, whenever a query comes to the processor, it will be asking the RAM for a specific data. So what the RAM will do, RAM don't know where the data is stored. It will just copy the block from a hard drive. It will give to the processor. Check whether this block one is having a data or not. So processor will check, no, this is not the appropriate data, or this is not the correct data. Again, what the RAM will do, RAM again will take that particular block and paste or replace it back to the secondary storage. So this process will be there. So checking the number of disks will be more if you don't know the exact which particular block is having the desired content. So this indexing will help us, okay, in a way that to optimize the performance of database by minimizing the number of disk access required when a query is processed. So index are created using a few database columns. Only very few database columns will be there in our index or indexes. So it will be basically of two columns. So index is a small table having two columns, right? The very first column will be the copy of primary key or the candidate key, copy of primary key or candidate key. And the second column contains the set of pointers for holding the address of the disk block where specific key value is stored. Specific key value is stored. As I have told you, in the index of a book, the first will be having specific key, next will be having the pointer. So specific key is the topic name, pointer is the page number. So same like this, we will be having search key and a data reference. The search key will be called as key, data reference will be called as pointer, data reference will be called as pointer. So this together will be called as our index in database, index in database, index in database. So let's see how we are going to see the indexing. Indexing is defined based on indexing attributes. Simply we are not going to define the indexing or index in a database. To define the index in a database, we have to consider certain things. So what are the different things or the constraint or the things we are going to take into the consideration while creating an index on a database? So very first attribute which we are going to consider for creating a index in database is access types. Is access types. What is an access types? This refers to the type of access, such as value based search or range based search. Are we searching based on specific value or a range of value? This is our first attribute of our indexing. Next, access time. What is an access time? It refers to the time needed to find a particular data element or a set of elements. Okay, if our search is based on value, so particular element, how much time it will take. If our search attribute is a based on range, so we are going to calculate the time based on set of elements. Next, we have the insertion time. Insertion time, what it is? It refers to the time taken to find the appropriate space and insert a new record. If the query is to insert a record into the table, so first we need to find out whether there is a space to insert a new record or not. If it is there, then we have to insert it. So to check and to insert, how much time it will take? So this also depends on the index. So indexing is a one of the attribute of indexing is insertion time. Next is we have the deletion time. So what it is going to check? Time taken to find the item and delete it. Time taken to find the item and delete it, as well as to update the structure. Whenever you are going to delete any record from the database, after deleting you are going to update the table. So the time taken to delete, to find first, next to delete, next to update, right? Next, we have the space overhead. Space overhead. What is space overhead? It refers to the additional space required by index. By index. If there is any requirement of additional space, how to look for that? Okay, will be considered in space overhead. So all these are the attributes that is going to help in constructing or in creating an index in database. Next, we have the types of index. Next, we have the types of index. What is the types of index? The index types is of three types. Okay, types of index are three types. First we have primary index, next we have cluster index, and the last we have secondary index. So by the name itself, primary index is a primary main. Next we have the secondary, then next we have the secondary, and then in between that we have the cluster. So let's see the first one, primary index. Primary index always defined on ordered data file. Ordered data file means sorted, either in ascending order or descending order. Either in ascending order or descending order. On a sorted data or a ordered data file, the primary index will be there, which is based on primary key of the field relation. This is very important. So primary index will be created on two parameters. First, ordered data files will be there. Next, primary key of the relation. So based on these two, we will be having primary index. Next, we have cluster. In cluster, we have the next scenario, that is define on order file. This is also defined on order file. Another is non-key field. Non-key field, it is not a primary key. Whereas in primary index, primary key. Order file, primary key. Next in cluster, unordered, oh sorry, in cluster we have the ordered and non-key. Ordered and non-key, both primary and cluster will be dealing with the ordered files, ordered data files. In primary we have the primary key, in cluster we don't have a key. In cluster we don't have a key. Next we have the secondary. What is secondary? Secondary will be unordered files. Unordered files, as well it is generated from candidate key of the relation. Sometimes we will be having candidate key, sometimes we don't have a key as well in secondary. So secondary index will take much time, more time compared to cluster. Primary index, easily we can get the data, or very fast the data retrieval or insertion or any operation on the data in primary index is very fast. Cluster index is somewhat slow compared to primary index. Secondary index is very slow. Secondary index is very slow because searching time for the specific block requires more time, more mapping, input output clock time will be more in secondary index. Okay, because we don't have a keys there. We don't have keys there. In primary we have a primary key. In cluster we are not having a key, but the data is ordered. In secondary, data is unordered as well as we don't have a key. So coming to primary index, we have two types. First is dense index, next sparse index. Dense index and sparse. By the name itself, dense means more, sparse means very less. So here index means we are going to talk about the mapping. We are going to talk about the mapping. Okay. In sparse mapping, we have very less mapping. In dense, we have more mapping. So what is dense? Stores all search key values. What is search key values? Already I have told you. Okay, needs more space, makes searching faster. Search key values means pointers will be having. Okay, all search keys, number of search keys, number of data available will be there in our dense index. Needs more space to store. The amount of blocks, the amount of data in blocks is equal to the size of index, is equal to the size of index, right? And it's the searching is very fast. The same amount of data we have, the searching will be fast. Sparse, only specific search key values will be there. Specific, or some search key values will be, needs less space and less maintenance overhead. So let's see in detail about dense and sparse. So in dense, data is sorted. Why it is sorted? Because it is a part of primary. It is a part of primary index. Primary index is a sorted data. Always works with the sorted data. So data is sorted based on primary key. Dense index stores all search key values, needs more space. Okay, hence make searching faster. Index records contain search key value and a pointer to the actual record on the disk. So let's see this example. Let's see this example. We have two different tables on the screen. One table is a hard disk or the hard drive. Another table is a primary index. In primary index, as we know, search key and a pointer will be there. In every index will be having search key and a pointer. So this is a primary index. Primary index means it is going to focus only on primary key of this particular table. So primary key of this table is a employee ID. Primary key of this table is a employee ID. So how many employees we have? Employee IDs we have 12 employee IDs we have, right? Divided into different blocks. In each block we have 4 employees. In each block we have 4 employees. So let's see how the dense index will be there. Dense index. So we have the search key of a primary index, okay, and a pointer. Each search key is divided into different blocks as a 1 2 is a one block, 3 4 is a one block, 4 5 5 6 is a another block. So let's see this first mapping from search key 1 to employee id 1, search key 2 to employee id 2. So like this, so on, 3 to 3, 4 to 4, 5 to 5, 6 to 6, right? So the number of search keys is equal to the data inside the each block, right? Search key is equal to data inside the each block. The number of search keys equals to the data inside the each block. So these are our block 1, block 2, block 3. These are our block 1, block 2, block 3. In each block I have 4 different data, 1 2 3 4, 4 employees. So let's see the number of pointers. We have 4 pointers. So pointers or the search keys equal to the data inside the each block. So if we have such type of mapping, this mapping is called as dense mapping. Okay. So next, this is called as our dense map. Secondary index. So when to use a secondary index? First is the data will be unordered. Data will be there. Next, non-key or key-based search. First is unordered. Data is unordered. The time will be more for searching. Next, non-key or key-based search. This is also complex. As well as the data will be already having a primary key. So you cannot consider the primary key, or you cannot take primary key into your search. So already primary index is there. Now you want to search another index. So that is our secondary index. So secondary index, when we are going to use, when the data is unordered and non-key or key-based search is required. Data searching requires more time here as compared to cluster. Why? Because already data is unordered as well as non-key. So obviously you can think about this, how much time it will take. Secondary index is of dense index type, where all search key values pointing to specific block or the content inside that particular block, right? So let's start with our secondary index. So to start with the secondary index, the secondary index will be having a primary index which is of dense type. So as you can see, I have the hard drive and a primary index of dense type. So whatever the entries I have for the first block, all the pointers is going to point to that, all the pointers, right? So search keys 1 2 3 4, I have index values, okay, and the data inside the block is 4. So all 4 pointers. So dense type, I have dense type of primary index I will be having for secondary index, right? So this is our dense index. So let same dense index, I have this whenever a query is there to search the employee from by using a employee ID, I will be using a primary index. Now I want to search the data. I want to search the data from the database based on Aadhaar card. But Aadhaar card number in this table is not a primary key. Is not a primary key. So here our primary index fails. Here our primary index fails. Now how we have to achieve, how we can search the data, right? So when you need to search data other than key of primary index, such as Aadhaar card number, which is also a unique key in a database. So how you are going to do? So what I am going to do here is, as you can see, the Aadhaar card data in the table is not sorted one. So when we are going to consider the secondary index, the first is data is unordered. So here Aadhaar card number data is ordered, not ordered. So very first thing what I'm going to do here is, this Aadhaar card data is unordered. So I'm going to make this data in ordered form in my secondary index. In my secondary index, I'm going to first sort the data of Aadhaar card. So I have sorted the data of Aadhaar card 124, 125, 128, 157, like this 896. I have sorted that particular data. Now This secondary index is of which type? Dense primary index. Dense primary index means all the search key values will be mapped to the all the blocks, to the different blocks of respective data. So let's see this one. 124 is mapped to 124, 125 Aadhaar number maps to 125 Aadhaar number, 128 maps to 128 Aadhaar number, 157 is mapped to 157, like this. So this is our dense mapping. This is our dense mapping. So always secondary index is of dense mapping, as well as this is a key based. It is a key based secondary index. Key based secondary index, right? So all the blocks I have here. All the blocks I have, right? So this is all about our secondary index based on key, based on key. Secondary index based on key value, that is a unique key of a table. Let's see this second case. Here I have the dense primary index is already there on the screen. Now whenever a requirement is there, that is I want to find out the employee name. I want to search the data with the help of employee name. As you can see in the data, employee name is always in every organization, the employee name will be repeated. Duplicate values will be there in database. So as you can see, Ravi, Raju, Sham, Ravi. In each block I have, in this first block 2 times Ravi is repeating, but their employee ID, their Aadhaar number are different. But my constraint here is I want to search the data based on non-key. In this non-key are our employee name and Aadhaar. Key is employee ID. Already the index is there for the employee ID, that is a primary index. Coming to the Aadhaar, in a previous slide I have shown you how to create the secondary index based on key. Now I have to create the secondary index based on employee name, which is a non-key. So when you need to search the data other than key of primary index, okay, such as ename, which is non-key and having duplicate values in a database table. So whereas in previous case it was Aadhaar card was a key and having a unique values, whereas in this case ename, which is a non-key as well as duplicate value. So in this how we can, so ename, you can see it is a duplicate values. So for this I have to create the secondary index for this. So what I'm going to do here is, in secondary index I'm going to keep the unique values. I'm going to create the unique values. In secondary index search key Jay, I have the first Kumar, Raju, Ravi. In the next block Sai, Sham, Sonu. I have all these search key values and these respective pointers. Coming to Raju, as you can see it is repeating 3 times. So I'm going to create Raju another block 3. For Ravi is also 3. For Sham 2. So what is this called as? This is called as my bunch of record pointers. This is called as my bunch of record pointers. This is called as my bunch of record pointers of Raju, Ravi and Sham. Raju, Ravi and Sham. So secondary key pointer of Raju will come to this bunch of pointers. From this Raju, the pointers will go to the hard drive, okay, or to the respective table. So let's see this Raju. So I'm mapping the Raju, okay, I'm mapping the Raju of secondary index to this bunch of record index, or the records. From this Raju is mapped to the block 1, block 2 and block 3, right? Next Ravi. From search key I have mapped to the Ravi record pointer. From this Ravi record pointer, Ravi is mapped to the block 1 Ravi 2 times and a block 2 Ravi 1 time, as you can see on the screen. So this is called as my intermediate layer. This is called as my intermediate layer of my secondary index, right? So this is all about our secondary index based on non-key value. Secondary index based on non-key value. Let's see the quick recap of our today's session. What is an index in database? A database index is a data structure. It is a data structure that improves the speed of data retrieval. That is going to improve the speed of data retrieval operations on a database. So it is used to locate and access the data in a database table quickly. This process is called as indexing. As well as index will help or optimize the data retrieval from the database. Secondary index. So secondary index, by the name itself, it will be the secondary index in our indexing. We will be having primary index, upon that we will be having a secondary index. So when we are going to use a secondary index, already I have told you in the beginning of the video. Now just in recap, defined secondary index is defined on an ordered data file generated from candidate key or non-key relation of the table or the database. Secondary index is of dense type index. What is a dense type index? All search keys will have pointers from data table to index table. Coming to time complexity, more than cluster index. So in the description, I will be giving you the link of primary index and secondary index. Please watch the videos and learn primary index and cluster index from my videos. Thank you. Please subscribe to my channel, like and share my video. Thank you.